Good morning, Chem 113, and you have been wishing for a Festive Friday demo, and here it is. It's Friday, we're festive, we're going on with this. So this is a demo that I would do normally this week for electrochemistry. I'm going to teach you how to polish silver without degrading the silver. Now normally, well, I imagine very few of you actually polish silver. I don't do it very often. But traditionally, the way that it's done is that you have this paste and you rub it on the silver and it takes off a layer, and it's taking off the oxidized layer of the silver. Well, I'm going to show you how to do it electrochemically. So first thing, I've heated up some hot water. Or heated up some water, so now it's hot. And my cameraman says, let's tell him what the temperature is. It's like 170. Okay? It's warm. To this, I'm going to add some baking soda. Some. Okay? And now I have various silver items that are slightly tarnished. And I'm going to loosely wrap them up in tinfoil. I want the foil to be touching the parts that are tarnished, and I'm going to drop them in. Okay. And then this is where it's not very exciting. Like if we were doing this in class, you'd be like, this is the lamest thing ever. We have to wait. But while we're waiting, I'm going to show you the chemical reactions. Okay, so we're just going to let that sit. Okay, so now we're going to look at the chemical reactions. This is a spontaneous reaction because we didn't have to really do anything. I mean, the hot water just makes it go faster. So first we're going to look at the standard reduction potentials. And so if we go to the table, aluminum 3+ plus 3 electrons produces aluminum solid, and that's a negative 1.66 volts. Silver plus 1 electron goes to silver metal, and that's 0.80 volts. Okay, so what we have going on, so we're wanting to take this silver plus over to the silver, okay? And in order for, so we're gonna reverse that top reaction. So it's the aluminum goes to Al3 plus 3 electrons. So this is a reduction, this is an oxidation, okay? Now, in order for us to add those two reactions together, of course, the electrons have to cancel. And we have 3 electrons here, only 1 here, so we need to multiply this by 3. So that reaction will be 3Ag plus 3 electrons goes to 3 silver. Okay, so now everything on the left side, anything that doubles on the left side and the right side will cancel. So these 3 electrons cancel with these 3. And my overall chemical reaction that's happening in my it's not a graduated cylinder, it's a measuring cup. 3 silver plus aluminum goes to aluminum 3 plus 3 silver. Okay? And a lot of times in class, students will say, well, does it matter which I put first? It doesn't. Okay? Like, just make sure you have things on the correct side. Okay. I think we should look to see what happened.
Can we calculate the voltage?
Oh, let's calculate the voltage. Thank you, cameraman.
We need a script for her.
The cell potential. So we know it's always the cathode minus the anode. I'm just excited about the results. Okay, and we know at the cathode is where reduction takes place, at the anode is where oxidation takes place. So at the cathode, we're going to put the silver potential, 0.8 volts, and we're going to subtract the aluminum potential, which is being oxidized. So we have a negative 1.66 volts. And so the overall cell potential there then is 2.46 volts, a positive value, spontaneous reaction. And what do you suppose delta G? I'm guessing their delta G is going to be less than 0 and K is going to be greater than 1 for
And
this
you don't
reaction.
Try to multiply that 0.8 by 3, because that's a common mistake.
Correct. That the number of electrons has nothing to do with the standard potentials. Okay, let's see what we have. Ooh, that's a little hot. So I'm just going to unwrap. And one of the things that sometimes we see is that the aluminum foil gets a little discolored, and we'll see if one of these pieces is. Like definitely I can smell sulfur, and the sulfur is because the tarnish is actually due to sulfides and oxides with the silver. Now that piece got shiny, but there's still some tarnish there on the edge, and I probably would just needs another soak. It's been in here at least 10 minutes. Let's see what's in this one. Oh yeah, see how nice and shiny that one is now? That's awesome.
You sure the other one's really silver?
Yeah.
Yeah, those
But
shiny.
the more tarnished they are, so typically if something doesn't come out the way I want it, if I want it better, I just put it back in. Sometimes I add a little more hot water. You definitely, by rubbing it a little, helps get some of that off. But those look better. They look shinier than when I took them out of my jewelry box this morning. Let's see this. Oh yeah, that's really nice. Now the caveat to this is that you want to be sure that you're only doing this to sterling silver and not to pewter. Pewter is an alloy that has tin in it, and the tin will be oxidized before the silver is reduced, and that could be problematic. That looks really nice. Woohoo. Yay. Okay, hope you all are staying healthy and not going too stir crazy, and yeah, I wish I could be harassing you in class right now. Come and visit Zoom office hours. It'd be fun to see you, and have a great weekend.